So what are significant figures? And you might have heard this in your chemistry class, but significant figures are an essential way of counting important digits that matter in any given number. And this is very important in chemistry because it allows scientists and also us to write down calculations and numbers in a very concise format that is efficient with what we have to do. So, in order to count how many significant figures there are in any number, so for example, if we are to count the number of significant figures in the number 2304, we have to categorize each digit and we have to see what type of digit this number contains. And we can categorize this into two main categories. First of all, we can categorize it into non-zero integers. And non-zero integers are numbers that go from 1 to 9. So for example, 2, 5, 7, and etc. These are all digits that are integers but aren't zero. So for example, if we use the knowledge that we have just learned, the number 2341 would contain 4 significant figures. And this is due to the fact that every single digit in this number are non-zero integers, so they will be counted as significant figures. So when we are counting the number of significant figures for this number, we would count 1, 2, 3, 4. So there will be 4 significant figures. Now once again, if we have a decimal such as 23.12, every single digit in this number are not zero, but they are integers. So they will be all counted as significant figures. So there will be 4 significant figures in the number 23.12. Now, if we have a bigger number such as 23415.2, the same concept applies. Every single digit in this number aren't zero, but they are integers. So every single digit here will be counted as significant figures. So there will be 5 significant figures. Now the second category of digits are obviously, as you might have guessed, zeros. But for zeros, it's actually slightly more complicated than non-zero integers because we have to further on case evaluate this. So when counting significant figures, we can categorize every single zero into 3 main categories. First of all, leading zeros, which are zeros that are located in front of integer digits. The second category would be captive zeros, which are in between integer digits. And the third category would be tailing zeros. Now, first of all, leading zeros, if we have an example of 0.0234, the leading zeros in this number would be the 0 here and the 0 here, because there are no integer digits in front of these two zeros, so these two would be considered leading zeros. If we have another number of 0.00304, the leading zeros in this number would be these 3 zeros here. These would be all considered leading zeros. And leading zeros in any case are not counted as significant figures. They are never counted, no matter what. So if we have an example of 0.023456, in this decimal number, these 2 zeros will be considered leading zeros. And every single digit after that are integers. So there will be 5 significant figures. Now, the second category of zeros are captive zeros. Now, captive zeros are quite self-explanatory, and for example, if we have a number of 2005, the numbers that are the zeros that are in between the integer digits of 2 and 5, right over here, these two zeros, are both captive zeros. Another example are 2.0204. And the captive zeros in this situation would be the zeros right over here and right over here, because there are integer digits surrounding these zeros. So they're considered as captive zeros. Now, captive zeros are always, no matter what, they are always counted as significant figures, no matter what. So for example, if we have another example of 0.2004, the captive zeros in this case would be right over here, as they are surrounded by non-zero integer digits. So 1, 2, 3, 4, there will be 4 significant figures in this number. Now for the last category of zeros, tailing zeros, these, to tell you the conclusion up front, are a bit more complicated. We have to further case evaluate this into two main categories. If a decimal point exists or not exists or doesn't exist. Now, a decimal point is simply a dot. So for example, in the number 23.04, this number would be counted as a number that has a decimal point because there is a decimal point right over here. Another example of a number that has a decimal point would be 122.0. Even though this is an integer, this is counted as having a decimal point. So if it has a dot in the number, it's a decimal point. Now, tailing zeros, on the other hand, are zeros that are behind every single integer digit. So for example, 0.0230040. This zero right over here will be considered as a tailing zero. And these two will be considered as captive zeros. And these two will be considered as leading zeros. Another example is 0.2000. These numbers here, these three zeros, are considered as tailing zeros, as they're all behind an integer digit of 2, and there are no present integer digits after them. Now, for tailing zeros, if there is a decimal point, tailing zeros are always, no matter what, counted as significant figures. On the other hand, if for any decimal or integer or any number, if there are tailing zeros but there are no decimal points, no matter what, the tailing zeros aren't counted. And decimal points. Now, to cap it all off, there are two main types of digits in any given number. Non-zero integers, such as 1 from 9, and zeros. And if there are non-zero integers in any number, they are always counted as significant figures. They're always counted. And for zeros, we can categorize them into three main categories: leading zeros, captive zeros, and tailing zeros. Leading zeros are zeros that are in front. Tailing zeros are zeros that are behind, and captive zeros are zeros that are in between integer digits. Now for leading zeros, they are always counted as significant figures. They are never counted as significant figures, and captive zeros are always counted as significant figures, and tailing zeros are counted if there are decimal points, and they aren't counted if there are no decimal points. So to give a few more examples, the number 2304.0010. To count the number of significant figures in this number, first of all, we have to identify how many non-zero integer digits are there. So there is 2, 3, 4, and 1. So these will all be counted as significant figures. Now, looking at the zeros here and here, these are all captive zeros because they are in between integer digits, such as 3, 4, 1. And these are all counted once again as significant figures, as captive zeros are always counted as significant figures. But for this last zero here, this last zero behind this 1, this zero here, this is a tailing zero. This is a tailing zero because it is behind all integer digits. Now for tailing zeros, we have to see if there is a decimal point or if there isn't a decimal point. Now, in this number, luckily, there is obviously a decimal point right over here. There's a decimal point. So tailing zeros would also be counted. So in this number, in conclusion, there are in total 7 significant figures. Now to give another example, for the number 0.023040, to count the number of significant figures in this number, first of all, we have to identify where the non-zero integer digits are. In this case, this would be 2, 3, and 4. These are all counted as significant figures. And this 0 in the middle is a captive 0, and hence would be counted as a significant figure. And this 0, on the other hand, is a tailing 0. And tailing zeros are counted if there is a decimal point. In this case, there is a decimal point. So this tailing 0 would also be counted. Now, on the other hand, these two zeros that are located in front of this number, these are considered as leading zeros. And leading zeros, as I've mentioned before, are never counted as significant figures. So in conclusion, in this number, there would be 1, 2, 3, 4, 5 significant figures.